Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to start new chapter, that is Organic Chemistry. Organic Chemistry, some basic principles and techniques. P block elements I have finished completely. Now I am going to start Organic Chemistry, some basic principles and techniques. In the previous classes, I have discussed the element carbon has the unique property called catenation property. Last class, previous class, I have discussed carbon has the unique property called catenation, due to which it forms covalent bonds with other carbon atoms. It also forms covalent bonds with atoms of other elements like hydrogen, oxygen, nitrogen, sulfur, phosphorus, and halogens. The resulting compounds are the resulting compounds you will study in this separate branch of chemistry, or you can tell the resulting compounds of carbon or compounds of carbons are studied under a separate branch of chemistry called organic chemistry. Organic chemistry is the branch of chemistry which discuss the compounds of carbon or carbon containing compounds is studied under the separate branch of chemistry that is called organic chemistry. General introduction, I am talking about the this organic chemistry. Organic compounds are vital for sustaining life on Earth and include complex molecules like genetic information bearing deoxyribonucleic acid DNA, deoxyribonucleic acid DNA, and protein that constitute essential compounds of our blood, muscles, and skin. Organic chemicals appear in materials like clothing, fuels, polymers, dyes, and medicines. These are some of the important area of application of these compounds. Science of organic chemistry is about 200 years old. Around the year 1780, chemists began to distinguish between organic compounds obtained from plants and animals and inorganic compounds prepared from mineral sources. Berzelius, a Swedish chemist, proposed that a vital force was responsible for the formation of organic compounds. However, this notion was rejected in 1828 when F. Holler synthesized an organic compound urea from an inorganic compound ammonium cyanate. This question is asked. Urea is the first compound which is obtained from lab, which was synthesized in lab from an inorganic compound ammonium cyanate. First compound is urea, which is synthesized in lab from an inorganic compound ammonium cyanate. And ammonium cyanate, NH4CNO, when it is heated strongly, NH4CnO, when heated strongly, it converts to urea. Then ammonium cyanate is inorganic compound. Now from inorganic compound, you got organic compound, NH2CO NH2. It is called urea. The pioneering synthesis of acetic acid by Kolbe in 1845 synthesized acetic acid CH3COOH. COOH is called carboxylic acid. Then CH3COOH is acetic acid synthesized by Kolbe in 1845, and that of methane by Berthelot. He has prepared methane in 1856, and by this way scientists or chemists showed conclusively that organic compounds could be synthesized from inorganic sources in laboratory. The development of electronic theory of covalent. The development of electronic theory of covalent bonding ushered organic chemistry into its modern shape. This electronic theory of covalent bonding taken organic chemistry into its modern shape. Now I am going to discuss tetravalency of carbon. Shape of organic compounds. Tetravalency of carbon is responsible for shapes of organic compounds. Already I have discussed last class about tetravalency of carbon. Means carbon has maximum valency 4. Carbon has 4 electrons, 4 orbitals. That is also called valency. 4 electrons, they can make bond with others. The shapes of carbon compounds I am going to discuss. How tetravalency is responsible. Tetravalency of carbon is responsible for shape of carbon compounds. I am going to discuss. The knowledge of fundamental concepts of molecular structure helps in understanding and predicting the properties of organic compounds. I have discussed, now you are knowing that tetravalency of carbon and the formation of covalent bonds by it are explained in terms of its electronic configuration and the hybridization of S and p orbitals. Alright, I have discussed S and p orbitals. If both orbitals will mix, then they will hybridize. Hybridization is just a process. Hybridization is a hypothetical process. Hypothetical, actually it does not happen, but if you will not consider this concept, then you can't understand the shape and properties of the organic molecules. And so this hybridization is a hypothetical process. Then here in hybridization, what happens? That different orbitals will mix and they will redistribute energy, and after mixing they will make same number of orbitals. How many orbitals mixed? In the same number they will mix the orbitals and they will have now equivalent energy. Then this process is called hybridization, and orbitals are called hybridized orbital. Now they have, in the same number, they have equivalent energy. If one s and one p orbital will mix, then it will form sp orbital. 1s 1p, 2 orbitals mix, then it will form 2 orbitals, sp sp, 2 orbitals. If 1s 2p will mix, then it will form 3 orbitals, 3 different type of orbitals, means sp2 sp2 sp2. 1s 2p, total 3 orbitals mixed. Then after that they will mix 3 orbitals after redistribution of energy, sp2 sp2 sp2. Sometimes 3 orbitals, 1s 3p orbitals will mix, and they total 4 orbitals they will mix, and they will form 4 orbitals, sp3 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 sp3, total 4. Like that way, sometimes s, p and d orbitals will also mix, 1s 3p and 1d, then it will form sp3d orbitals. Okay, and s and p orbitals, generally it will form linear orbital, a straight line like that, linear sp. And this is very, very important things I am telling you now. sp orbital will be give a linear shape, linear straight, and sp2, total 3 are there, 3 orbitals, then it will give triangular shape, triangular, and sp3, total 4, then sp3 will give tetragonal, tetrahedral shape, tetrahedral, 4 points you will get, okay, 4 down and 1 up, okay, and when you will join all point, then it will give tetrahedral. 4 just like a square, or you can tell this thing rectangular, and 1 will be upside. You join all points, then it will give a shape of tetrahedral. Methane has a tetrahedral shape, CH4, CH4, okay, C, that 4H, 4C will be in the middle, and 4H is there, 1H will be up, and 4H will be in one plane, just like one page, either book or notebook, one page, that is all are in the same plane, and one will be up, and just to join all points, and all with carbon, H, 4H down, C in the middle, and then 4H, and 1H will be upside, okay. Then this will be CH4, C will be in the middle, and 4H will be there. Then it will form CH4, 1H will be up, okay, keep in mind. Then it will be CH4, total 5. Then this I have told about this hybridization. Like that way, sometimes 2D orbital will mix, then it will form sp3d2. Then sp will form linear, and sp2 will form trigonal. 3 are there, 3 points are there, that's why trigonal. And sp3, total 4 points are there, that's why it will form tetragonal, okay. Like that way, if sp3d are there, then total how many became? 3, 4, 5, then pentagonal, it will form pentagonal. If one more d is there, 2 d orbitals are there, sp3d2, then 6 are there, total became 6, then hexagonal. Then by seeing the hybridization, you can understand that what will be the shape. Then that I have discussed you, that now tetravalence of carbon and the formation of covalent bonds by it are explained in terms of its electronic configuration and the hybridization of S and P orbitals. It may be recalled that formation and the shape of molecules like methane Methane is called CH4, 1C, 4 hydrogen, CH4. Ethene, C2H4, 2 carbon, 4 hydrogen, C2H4. Ethyne, then it is a C2H2, 2 carbon, 2 hydrogen, that is the ethyne. These are explained in terms of the use of sp, you can say sp3, sp2 and sp hybrid orbitals by carbon atoms in the respective molecules. If you are talking about the CH4, then in CH4 carbon is joined with 4 hydrogen, then 4 points it is joining. Then it's here which hybridization is there? Then sp3, because 4 hydrogen is there joined with carbon. Then 4 hydrogen means carbon has joined with 4 hydrogen. It means 4 orbitals. 4 hydrogen means 4 orbitals. That's why it is called sp3 hybridization. And ethene, C2H4, double bond is there. C2H4, carbon, 2 carbon, between the 2 carbon, 2 lines are there, means 2 double bond. And each carbon has joined with 2 hydrogen. Each carbon has joined with 2 hydrogen. Then now here, again here, very important things I am telling you now. Double bond means one will be the sigma bond and other bond will be pi bond. If 2 bonds are there, double bond is there, carbon double bond, then it means one is sigma bond, end on overlap, end on or axis wise overlap. Then by the axis wise overlap or end on end on overlap, sigma bond is formed and orbitals will overlap too much. They will overlap much. That's why bond will be strong. That's why sigma bond is stronger than pi bond. And pi bond, what happens? That is the lateral overlap. Due to the lateral overlapping, pi bond is formed. Also you can tell sidewise overlapping. Then due to sidewise overlapping or lateral overlapping, pi bond is formed. From the plane, 50% orbital will be up and 50% will be down. Then suppose carbon, that 50% one orbital will be perpendicular up and 50% down. Like that way other carbon also, that generally it will be unhybridized. Unhybridized orbital means orbitals which will not take part in hybridization, but they will have electron, but they will not take part in hybridization. Then that is called unhybridized orbital. Then due to unhybridized orbital, this pi bond is formed. Sidewise are also called lateral overlapping. This pi bond is formed because lateral overlapping will be less. Both lobes will just simply it will touch. It will not overlap too much. That's why pi bond will be weak bond. But whatever they are overlapping, in the middle electron will come. When two you can say orbitals will overlap, then in the middle, in the common place, electron will come. Okay, then but this overlapping will be less. But in end-on overlapping, axis-wise, sigma bond overlapping will be more. And common area will be more. In that, both electron will come. One electron from both carbon. Then this is hybridized in sigma bond, hybridized orbital will take part, but in pi bond, unhybridized, and both electron will take part, and they will come in the common place where they are overlapping in that place. Then because of less overlapping, it is weak. Then pi bond is weaker bond than sigma bond. Then now I have told a very important point. If two bonds are there, then one bond is sigma bond and other bond is pi bond. Now like that way, if triple bond is there, carbon-carbon, 3 bonds are there. Between carbon, 3 bonds are there, then one will be sigma bond and 2 bonds will be pi bond. Okay. Then here, 2 unhybridized p orbital will take part in bond formation. Means on the carbon, 2 unhybridized p orbital will be there, and other carbon again 2 p unhybridized orbital will be there. Then parallelly they will overlap, and 2 pi bond it will form. Then in triple bond, 2 bond will be pi bond and 1 bond will be sigma bond. Question is asked that they will give the structure bond they will give, and they will ask just to tell me how many pi bond is there and how many sigma bond is there. Okay, they will give the structure. They will give double bond, triple bond, and carbon is attached with H like that. Maybe carbon, suppose carbon is carbon 2 bond is there. Then carbon has a total 4 valency. Then now 2 valency is involved in making double bond. 2 electron is involved. Then now other 2 electron of 1 carbon, they will overlap with hydrogen, and they will make sigma bond. With H, they will make sigma bond, CH. Both will overlap. S orbital will overlap with carbon orbital. 2 electrons are now remaining, then both will overlap with 2 hydrogen, and they will make CH bond. Like that way, other carbon also 2 electrons are remaining, then that 2 electron will again overlap with 2 H, and they will make CH bond. Then like that way in C2H4, CC will be double bond, and both carbon will be joined by 2 hydrogen. Then it is C2H4. Then now how can you count how many double bond is there, how many single bond is there? Then carbon double bond is there. Then it is 100% sure that one is sigma bond and one is pi bond. Then total how many sigma bond is there in C2H4? Then now 2 CH bond is there on first carbon and 2 CH bond is on second carbon. Then 2 plus 2, 4 sigma bond, and 1 carbon between carbon sigma means 5 sigma bond. How many pi bond? Only 1 pi bond. Like that way they can ask the question that in this ethine means acetylene, how many sigma bond is there, how many pi bond is there? Then CC, between CC triple bond is there, then 1 sigma bond and 2 pi bond. And then now carbon has 4 valency. Then now see 3 electrons are involved in making triple bond. Each carbon 3 electrons are now involved in making, means 3 orbitals. They have made 3 bonds. Correct? Then one electron is remaining. 1 electron on each carbon is remaining. That will make bond with hydrogen, CH, and the other carbon also they will make CH. Then total how many sigma bond? Then CH means sigma bond. Then 1 carbon CH bond, other carbon CH bond. Then 2 sigma bond and carbon 1 sigma bond. Total 3 sigma bond. And pi bond how many? 2. Like that way question will be given, long branch they will make. They will give question long in that. Now I told about only 2 carbon, maybe 3 carbon, maybe 4 carbon. Correct? Then each carbon has 4 valency. Always you keep in mind. If they have given, suppose 4 they have given, 4 carbon. Then for each carbon, you have to consider 4 valency. Then if a double bond is there, then okay. That is 1 sigma bond, 1 pi bond. Rest carbon they will have, you count 4 valencies there, means third and fourth carbon. First, second, third, 4 carbons are there. Then now consider the third carbon. And third carbon is joined with second and fourth carbon also. That suppose total 4 carbons are there. All carbons are joined with each other by sigma bond. Suppose any one carbon has double bond, any one. Then now each carbon 4 valency will be there. Then 1 double bond is only there. Out of 4 carbon, only one place double carbon is there. Carbon double bond. Other are single bond. Then rest will be how this tetravalency will be completed. Then rest bond will be with hydrogen bound. Correct? Because carbon will make with left and right. One carbon they will use, one electron they will use. Then now 2 electrons are remaining. Then that 2 electron they will make bond with 2 hydrogen. Obviously you should understand that rest 2 electron will join with hydrogen, and with hydrogen they will make sigma bond. Hence you can count easily. Suppose 4 carbons are there, that is called butane. Suppose between the 2 carbon 1 double bond is there. Then now 2 carbon is, now 2 carbons have only one bond only. Carbon 1 bond and rest will be with hydrogen. Last carbon will make 3 hydrogen bond, last carbon. Okay. Then actually it has to complete tetravalency. Then 1 carbon is joined with other carbon, then 1 electron is involved. Then rest 3 electron, what they will do? Then they will make bond with 3 hydrogen. Then 3 sigma bond is formed in the last carbon. And first carbon double bond is there, suppose. Then 2 electron is involved. Now 2 electron is remaining. Then that 2 electron will make bond with 2 hydrogen. Hence 2 sigma bond in the first carbon. And last carbon 3 sigma bond. Then 3 plus 2, 5 sigma bond. And third carbon 2 electron is involved. Left side, right side, one electron. And remaining 2 electron they will make bond with hydrogen, 2 hydrogen. Then total hydrogen bond 3 plus 2 plus 2, 7. 3 plus 2, first 2, last 3, and in the middle 2. Then 3 plus 2, 5. 5 plus 2, 7. Okay. Then like that way each carbon you have to consider. One more thing, sir. First carbon 2 hydrogen was there, CH2, and second carbon double bond is there, and one second carbon 3 electron is involved, means with double bond 2 electron, and with neighboring bond 1 electron, 3. 1 electron is there, that will also make sigma bond with hydrogen. Means now it will come 7 plus 1, 8 sigma bond. 8 sigma bond. Now count everywhere 4 valency is there. Carbon is satisfying its 4 valency. Always you count that it is satisfying 4 valency or not. If double bond is there, then 1 hydrogen you have to write. Because 2 and nearby one this will be there, other carbon, then 3. Then one will be one H bond it has to make. Then always you see, count tetravalency of carbon is satisfying or not. If not, then H you have to write there. H you have to write there. If triple bond is there, then only one bond it will make with hydrogen. Carbon will make only one bond with hydrogen because 3 electron is involved. Always 4 electron must be, you can say, involved either in double bond, triple bond, or with the help of hydrogen. Okay, this question is asked in examination. Then only on this concept, now any type of question, either branched or straight chain, branch chain, cycle form. Carbon can make compound in many ways. A straight change, C, also you can join and fill it by hydrogen. Okay, like that way. Branched also, suppose 5 carbons are there, 4 carbons are there, then 3 may be straight, 1 may be branch down, joined with other carbon in the middle. Or suppose 5 are there, then 4 will be straight and 1 will be down, joined with any carbon. This is called branched. Suppose it is 7, then 4 is straight and 3 will be, 4 is straight, 5 you can say straight, and 2 will be continuous, CS2 will be down, and rest you fill with hydrogen, keeping in mind covalency of 4. Then it can make branch also, it can make a straight also, it can make a cycle also. All carbon can join to each other. Suppose 3 carbons are there, then they can make a triangle form also. C, join all. It will become like a triangle. And all C, 2H you can add with hydrogen, CS2. They can make sigma bond with 2 hydrogen, all 3 carbon. Then it took a shape of triangle, that is called cyclo. Like that way, 4 carbons are there, then can make a shape of, you can say, a square or rectangle, C, just like a square or these things, rectangle. And each carbon 2H will come because only 2 bonds are making with carbons. Then CS2. Then this is also a cycle. Continuously all are joining. Continuously all are joining means cycle. Like that way, this I told 3-membered ring. Like that way, 4-member rings, rectangle or a square. Like that way, 5-member ring is also possible. 5 carbon will be there, all will be joined with each other, and all carbon will join with hydrogen to satisfy the covalency, 4 valency. Like that way, 6 carbon chain also is possible. Some of benzene, common benzene, 6 carbons are joining to each other, and all carbon will join with 2H to satisfy the these things, tetravalency. That time it will not benzene, hexane. That is called hexane. If benzene has alternate double and single bond, when double bond is there, then only one H you have to write, because double bond means one carbon is making one side double bond, other side single bond. Then 3 electron is involved. Then 4th is only one electron is remaining. 4th electron is remaining. Then only one hydrogen it will make bond with only one hydrogen. Then like that way, 3 in benzene, alternate single and double bond will be there. Double bond, single bond. Double bond, single bond means 3 triple bond and 3 single bond. Hence, carbon will have 6 hydrogen and 6 hydrogen. 6 carbon and 6 hydrogen. Carbon 6, C6, H6. Because the three triple bonds are there, three double bond is there. Three double bond is there. That's why wherever double bond is there only one hydrogen will be there. Correct? Then if you write the structure, then quickly you can understand. Then I was taking about the cyclic structure. Maybe triangular, maybe tetragonal, maybe pentagonal, maybe hexagonal. Okay, means triangular. After that I told you less like a square or this thing rectangle, that type of cyclic. All are the cyclic structure. Hexagonal is also cyclic, pentagonal is also cyclic. Hepta is also possible. Hepta, octa means 7 ring is also possible. 8 ring is also possible. Okay. Then these are called the ring structure. Then you, whatever with the structure, you count the how many double or double bond or triple bond is there and how many single bond is there. Just a count and then quickly you can respond that how in that compound how many single bond is there and how many you can say sigma bond, how many sigma bond is there and how many pi bond is there. Easily you can calculate and respond. In all competitive examination they will ask this type of question, maybe medical or engineering, even in other competition also. Then I have to given today I have given you very important concept. Okay, now if you will think like that then all complete organic chemistry will be easy. Okay, many other things you have to learn, only 1-2 things now I have told you. And now again I am continuing I am telling you more things. And what I have told now, I think this concept will, by use of this concept you can understand the many things of many reaction of organic chemistry also, and a structure of organic chemistry also. Okay. Hybridization influences new things. Now I am telling you, hybridization influences the bond length and bond enthalpy, means bond energy. That is also called a strength, bond strength in organic compounds. In organic compounds, organic compound I am talking about continuously if you will tell then it will look like inorganic, but I am giving some gap in organic. Okay, if you will organic and inorganic, it looks like that if you will talk continuously inorganic, hence I will give some gap in organic. Okay, not in continuous. Then hybridization influences the bond length and bond enthalpy in organic compounds, means strength, bond strength. The sp hybrid orbital contains more s character, new things, because 50% is there, sp 50% s, 50% p character. And in sp2 total 3 are there, then 2 p are there and 1 s is there, then 33%. S has 33% character. And sp3 3p and s, total 4, out of 4 only 1 s is there, then 25%. And in sp2 means now in sp3 total 3 is there, in 3 only 1 is there s character out of 100%, then 33.3% s character. Like that way you have to understand, if s is coming what percentage, that will have meaning, Then here the sp hybrid orbital contains more s character and hence it is closer to its nucleus. More s character means it is closer to nucleus. Nucleus is positively charged and form shorter and stronger bonds. That's why sigma bond is stronger, because it is closer to nucleus. Okay, nucleus and forms a shorter. Always a strong bond will be shorter and long bond will be weaker. Keep in mind. Okay, then this I'm talking about the S character. Due to the more S character, it is closer to its nucleus and forms shorter and stronger bonds than the sp3 hybrid orbitals. The sp2 hybrid orbitals is intermediate in S character between sp and sp3. Actually sp2 character will be between sp and sp3. sp is the 50% S character and sp3 is 25%. Then in between the two, sp2 will come. Then the sp2 hybrid orbital is intermediate in S character. S character I am talking about between sp and sp3. In sp 50% S character and sp3 25% and in sp2 33.3. Hence the length and enthalpy of the bonds it forms are also intermediate between them. Okay, that's why length, bond length I am talking about. The length and enthalpy of the bonds it forms are also intermediate between them. The change in hybridization affect the electronegativity of carbon. Another important point I am telling you. All are important point only. The change in hybridization affects the electronegativity of carbon. The greater the S character of the hybrid orbitals, the greater is the electronegativity. Very important things. The greater the S character of the hybrid orbitals, the greater is the electronegativity. Thus, a carbon atom having an sp hybrid orbitals with 50% S character is more electronegative than possessing sp2 or sp3 hybridized orbitals. This relative electronegativity is reflected in several physical and chemical properties of the molecules concerned, about which I will tell you. Okay, now just we have started. Now I am telling you some characteristics feature of a bond, a special feature, some characteristics feature of a bonds. In a pi bond formation, parallel orientation of the 2p orbitals on adjacent atom is necessary for a proper sidewise overlap. Already I have told you how pi bond is formed. I told you. Okay, pi bond formation. In pi bond formation, parallel orientation of the 2p orbitals on 2p orbitals on adjacent atom is necessary for a proper sidewise overlap. Thus, CH2 already I have discussed. In CH2 molecules, all the atoms must be in the same plane. Same plane means up down you have to not consider. Same page means just like a paper or book, one page. Upside you are not considering, down you are not considering. Just 4 point of page or paper, just to think. No height, no depth. No height, no depth. Only one plane, just like a surface. Okay, no height, no depth. If electron is up or down, that you have to not consider. You think that all are in one plane, just like a surface. Okay. in home surface is there or in classroom. That surface is considered just like one page. You are not considering molecules are up or down. All are in one plane. Then here in CH2 molecules, that is the C2H4, ethylene, ENE means double bond, and ethane, alkane, listen carefully, alkane, 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 ANE, that is the single bond. And if alkene you are writing ALKENE, ene means double bond. Here it is ethylene, ENE, in the end it means a double bond. Like that way, YNE, alkyne, ALKYNE, alkyne means triple bond. Don't forget, alkane, alkene, alkyne. Okay, slowly and slowly you will understand all the things. Then the p orbitals are mutually parallel, and both the p, how bond formation, how pi bond forms, that I am now explaining again, that the p orbitals are mutually parallel, and both the p orbitals are perpendicular to the plane of the molecules. Perpendicular to the plane of molecules, p only. Rotation of one CH2 fragment with respect to the other interferes with maximum overlap of p orbitals, and therefore such rotation about carbon-carbon double bond is restricted. The electron charge cloud of the pi bond is located above and below the plane of bonding atoms. Here you are talking about the p orbitals. I told you 50% up, 50% down. It is not in the plane. This is not in the plane, but other two carbon, 2 hydrogen in the plane, but pi bonds are not in the plane. They are you can say this up and down. That is this two electrons, that p orbitals that will be 50% up and 50% down. Okay, then this rotation, carbon-carbon between the carbon-carbon bond will be there. Okay, then rotation of one CH2 fragment with respect to the other interfere with maximum overlap of p orbitals, and therefore such rotation about carbon-carbon double bond is restricted. Means carbon-carbon double bond is there and CH2 is there. Then this CH2 will not rotate freely due to this double bond. Due to this double bond, CH2 will not rotate. Okay, restriction is there. Not freely it will rotate. The electron charge cloud of the pi bond is located above and below the plane of bonding atom. Here again I am telling you that electrons will be in the form of cloud. Cloud you have seen in rainy season. Cloud, like that way. Now actually you are talking about only this C2H2. Then their number of electrons are limited. You will tell how many carbons are there. Then 4 plus 4, 8, and 8 to 10 and to 12. Total number of electrons is 12. In ethylene, correct, carbon 4, 2 carbons are there, then 4 plus 4, 8, and 2 hydrogen. Then each hydrogen has one electron. Then total 4 electrons are there. But now you are talking, or we are talking here only for one molecule. Only for one molecule, not for 1 mole. 1 mole means Avogadro number 6.02 into 10 to the power 23. 6.02 into 10 to the power 23 molecule. See how many 10 to the power 23. How big number is there. Correct? Then if you will consider for 1 mole, then many electrons will be there. Many electrons will be there. 10 to the power 23 is not here. Very big. Very big. But here we are talking 1 molecule. Only 12. But you consider 1 mole. Then how many this molecule will be there? In each molecule 12. In each molecule 12 electrons are there. Then in 10 to the power 23 molecules, how many will be there? 12 into 6.02 into 10 to the power 23. Very big number. Then that time you will consider electron as a cloud. Electron is a cloud. Okay. Then now I think you have understood concept of cloud. Electron is also you can consider as a cloud. Then near the carbon, more electron will be there. Near hydrogen, less electron will be there. But anyhow, now you think only for 1 molecule, then easily you can understand. But electron cloud will be there. Then the electron charge cloud of the pi bond is located above and below the plane of bonding atoms. This results in the electrons being easily available to the attacking reagent. Okay, again important point. This 50% up, 50% down in bond formation P or whiter I told you. Then these results, this means 50% up and 50% down electrons are there. Then this results in the electron being easily available to the attacking reagents. If something is coming for the reaction, other molecules are coming with reaction to react with this molecule, ethylene, as for example, ethylene plus other, then now electrons are free, available, that's why they will react. Electrons are available, that's why other that is called substrate, substrate, SUBSTRATE. In organic chemistry, that molecule which is coming to react A plus B, then both are substrate, both are called substrate or reactant. Reactant is okay, common. Particularly organic chemistry, you will use that term. In organic chemistry, you will use that term substrate. Then this results in the electron being easily available in the attacking reagent. In general, pi bonds provide the most reactive centers in the molecule containing multiple bonds. Only there 2 bonds are there, then pi bond will first break. It will take part in the reaction. That electron will take part in the reaction. If a triple bond is there, then 2 bonds are pi bond in triple bond. Then that 2 pi bond first they will break, and SS is strong, that will not break easily. Then like that way they will react. Okay. Then pi bond first takes part in the reaction, and say this sigma bond will react in the end. Then now actually 1-2 example is there, already I have discussed. I will try to send some this type of problem. Now you have to just question only I am reading you. after that automatically you will think in mind and you can answer also, because concept already I told you. Problem is there, that question is asked in examination, then I am reading only question and you think in your mind, okay, obviously I am 100% sure you will get the answer. Then problem I am reading, how many sigma and pi bonds are present in each of the following molecules. Then first molecule is given CH, and after that double bond is there, again C is there, again CH is there, and again double bond is there, again CH3 is there. Simply I am telling you, you apply your mind, you can quickly answer also, that total 1, 2, 3, 4, 5, 3 to 5, 5 carbons are there, straight chain, 5 carbons are there, 1, 2, 3, 4, 5, 5 carbons are there, and out of 5 carbons there are 2 double bonds are there out of 5, means the beginning it is a double bond, first and second carbon double bond is there, and then third and fourth double bond is there. If you have pen pencil, you can note down also that first carbon and second carbon double bond is there, okay, and after that third and fourth double bond is there, and rest carbon just to fill hydrogen, just you have to satisfy the tetravalency, and then you count how many sigma bond is there and how many pi bond is there, total sigma bond, total pi bond. Okay, then first molecule I told you. Second molecule is C. In that 4 carbons are there, and carbon first and second double bond is there, and second and third again double bond is there, means in second carbon tetravalency is full, first and second double bond is there, and second and third again double bond is there, and other carbon you have to fill with hydrogen. It should be 4, always carbon should be 4, okay, tetravalency of carbon should satisfy. Then last is CH3, then obviously it will be CH3 because that carbon is joined with 3 hydrogen and one electron is joined with other carbon, correct. Then like that way, this second question I told you, CH3 double bond C, again double bond C with the third carbon, and again CH3, total 4 carbon and 2 double bond. Then only by seeing the question and just you will count the sigma bond and pi bond, you can answer very easily, okay. Now another problem is there, what is the type of hybridization of each carbon in the following compounds. Then this also I have discussed, quickly you can answer. These questions are asked in all competitive examination, keep in mind. Then now problem is there, what is the type of hybridization of each carbon in the following compounds. They have given 4 type of compounds are there, and you have to find out hybridization, types of hybridization. I told you na, sp2, sp3, sp3d, sp3d2, these are the different type of hybridization. Then now by seeing the molecule, you have to answer what type of this hybridization is there. Already I have told you, and I hope quickly you will answer. Then first problem is that first molecule is given CH3Cl. CH3Cl. Then now that is methyl chloride, CH3Cl. No double bond, no triple bond. All are single bond. Then single bond means what I told you. Single bond means sp3. sp3 means single bond. sp2 means double bond. The double bond is then sp2. And sp is there. sp then triple bond. Okay. sp3 means single bond. Okay. sp3 means single bond. And sp2 means double bond. sp means triple bond. Then now by seeing the molecule you can tell. Here you can see question is methyl chloride CH3Cl. No double bond, no triple bond. It means carbon is what type of hybridization is there in carbon? sp3. No single bond, no double bond. All are single, no double bond, no triple bond, only single bond. The single bond is sp3. Just quickly we answered. Now same way you can answer for the second question. That is the question is there CH3 whole 2 CO. CH3 whole 2 means one carbon in the center and two CH3 is joined, CH3, and one double bond is there with oxygen, CO. This is actually acetone, CO, and left side CH3, right side CH3, and then carbon again CH3, and in the middle COO in the middle, left side CH3, right side CH3. Then now you can say what type of hybridization is there? Think and answer. CH3, C, again CH3, and with the middle C, double oxygen, double bond is there, oxygen, CO. Then here you can take very easily, very interesting also, that only one double bond is there, CO. CO is double bond. Then double bond is there and CO, carbon is joining with oxygen. And then double bond is there means sp2, one sp2 hybridization is there. And other carbon, sp3 is there, CH3. Then one double bond means one sigma bond, one pi bond is there. Then the double bond only you count. Then one sp2 and one sp2. sp means sp2 hybridization is there and sp3 hybridization is there. Two types of hybridization is there in this molecules. That is the sp2 and sp3. Now third question, third molecule, that is a CH3CN, methyl cyanide, CH3CN. Here I want to tell you, cyanide means triple bond, C and N, triple bond is there. Then CH3CN, methyl cyanide. What type of hybridization is there? Then triple bond is there, C triple bond N. Then it means one sp is certain. One triple bond means sp is there. Carbon is sp hybridized. And other is the CH3, single bond. Then other type of hybridization is sp3. Then in this molecule, two type of hybridization is there, sp and sp3. See how easy is this. Now next question is there, fourth, 5 are there total. Then fourth molecule is HCONH2. HCONH2. Then now again you can see CO is there. Then CO means double bond. CO means double bond. C and O, double bond will be there. Okay. Then and NH2 not a problem. NH2 with the N, 2 hydrogen is attached. Sigma bond. That one double bond is there. Then in these molecules also you will find here that sp2 molecules are there. Okay. In D, sp2 double bond is there, sp2, and rest are actually one carbon is only there. Only for the carbon only they are asking. Only for carbon hybridization they are asking. Then only one carbon is there. Then there CO bond, that also it is attached with the CO. Then this is the sp2 hybridization. sp2 hybridization. And with hydrogen, this is the, but only one carbon is there. Only one type of hybridization is there, sp2. Nitrogen you have to not consider. Okay, according to the question, only carbon is sp2 hybridized. Now I am talking last molecule. They have given CH3 CH double bond, again CN. Then now you can see CH3 is there. Okay, CH3 CH is there. Then CH is double bond, and CN is there, means triple bond. Then now it is very easily CN is there. The CN is a triple bond, and CH double bond is there. It means double bond is there and CH3 is also there. It means sp3 hybridization is there, sp2 is there, and sp is also there. All three type of hybridization is there. And because CH3 that is a single bond. All single bond means sp3 is there. Double bond means sp2 is there. Triple bond means sp is there. Okay. Then it is very easy to find out hybridization. Question is asked. Now you can say this. Again, one more problem is there. Write the state of hybridization of carbon in the following compounds and shapes of each of the molecules. What I told you now, same type of things you have to think. You have to find out what type of hybridization is there in the given molecules, and new things they are asking, shape of each of the molecules. Shape. Then I told you single bond means linear. Single bond means linear. Okay. Then this can say SP that is the linear. SP is linear. Correct? S and P, only two are there orbitals, S and P. Then this will be a straight line. SP, already told you, linear. SP3, 3 points are there, the triangular. And if it is the 4 means tetrahedral. 4 means tetrahedral. Then now first you find out the hybridization. What type of hybridization is there? And then accordingly you can tell it is linear or triangular or tetrahedral. Then first molecule is given molecule is CH2CO. Then here double bond is there. CO double bond is there. Then it means sp2 hybridization is there. sp2 hybridization carbon is there. And when sp2 is there, then total 3 points, 3 electron. sp2 means 3 orbitals. 3 orbitals means just like a triangular. Hence its answer is sp hybridized carbon, and shape is trigonal planar. planar. Now second is CH3F. CH3F. Then this is the CH3, no double bond, no triple bond. CH3F. Okay. Then it will be sp3 hybridization. Single bond. All are sigma bond. Then sp3 hybridization. And when sp3 is there, then tetrahedral structure. Tetrahedral structure, sp3, 1s3p, total 4. Tetrahedral. Now one more molecule is there, that is the HCN, hydrogen cyanide. HCN, then CN means triple bond. Then triple bond means sp hybridization. sp hybridization is there, sp hybridized carbon. sp hybridized carbon. Then sp means linear. You can see how it is easy to find out a shape. Okay. Then today I am stopping only here. Many things I have discussed, and again many things are there to remaining to discuss. I will discuss slowly all the things. Okay. Thank you.